Have you ever wondered exactly what our universe is built from? Physicists have been pondering this very question for ages, attempting to derive a unifying theory of everything, or TOE. Two major fields of modern physics are quantum physics, or the study of the really small stuff, and general relativity, the study of the universe on the largest scale. The issue is, at their fundamental states, it's impossible for both of these theories to be completely true. Many physicists believe that the answer to this resounding conflict can be found within superstring theory, or string theory for short. This concept is one that depicts our universe in a giant tapestry, where quantum physics and general relativity are interwoven and actually become reliant on each other. We know that all of the matter around us, dogs, the moon, my mom, is made up of atoms. And when we look at atoms, we see that they're made up of even smaller things called elementary particles. Now, elementary particles are too small to actually see, but we can still identify them and calculate their interactions. In observing their interactions, we are observing the interactions of the fundamental forces of the universe. Weak force, strong force, and electromagnetic force are all observed in the interactions of elementary particles. The fourth force, gravitational force, is a model of the interactions between space and time themselves. They each appear to have a respective smallest particle, which are unable to be further divided. String theory, however, makes a further claim that if we were able to peer even closer at these elementary particles, we find that each point particle is actually a minute single-dimensional string. According to the theory, each and every particle is made up of a single loop, and each loop vibrates at a different frequency. The same way a guitar string vibrates at different frequencies in order to sound different notes, these tiny strings vibrate at different frequencies in order to make up the particles of the universe. In other words, the properties of each elementary particles, from its mass to its force, is determined by the exact vibrational pattern of its internal substructure, a string. Though string theory is an impressive contender in the search for a unifying theory of everything, we're unable to define many of its properties. This is due to a variety of reasons, one being that it requires a total of 10 dimensions to fully make sense. So, despite the vast questions that string theory raises, the mathematics and properties it consists of can be incredible pathways into many other aspects of physics. In other words, in math class, we start with the basics, addition, multiplication, and so on. It's only after we master the first steps that we can move on to the more complex ideas, such as integrals or differentials. If we understand the basics thoroughly, we can understand the complex next steps. We don't wish to define the universe with a single theory of everything for the sake of ending the need for all science. Rather, with a strong and foundational unifying theory, we can begin the next step in our journey of answering the age-old question: what exactly is our universe?